Thank you for joining this talk, which is not about myself, which is my name is Luca Alessandrini, but about like these amazing three entrepreneurs and companies which are really working within engineering materials and especially circular economy. And we are here meeting three companies which are PaperShell, which are Aquafil, and also Parastruct. And we're gonna talk about how they actually engineer their work through circular economy. And first, a very quick introduction about myself. And well, my name is Luca Alessandrini. I'm gonna moderate this talk. I'm a former designer, training engineer, working between materials, circular economy, industrial symbiosis. And quickly, just gonna present also the company I'm working with, which is called VCG.ai, which we do basically, we provide intelligence for circular economy and bioeconomy, and especially for circular supply chains. What we do basically is to provide our service in three main ways. First of all is to again map supply chain, find partners, and of course find alternative supply chains starting from either waste or either backward from a product that wants to actually be produced using second generation feedstocks. So we we draft all the new value chains and then we provide all the intelligence, and this can be done in three different ways. But I'm gonna quickly move on to the next panelist, which is, thank you, PaperShell. And if you can introduce yourself quickly.
Of course.
Here to.
Where do I have to press that one?
Okay, thank you.
Well, yeah, I'm here today to present about PaperShell, but first maybe I introduce myself. I am Fabian Hart. I am head of design currently at PaperShell, former head of sustainability, and I've been at PaperShell for 3 years now. The company itself, we are rather young for where we are already. We are 5 years old, and we are Swedish, a Swedish-based company with a factory in the heart of the furniture industry in Sweden, in Tibro. First, maybe for those who don't know, PaperShell is a material innovation. It is, as the name might suggest, based on paper. It is 100% biogenic alternative to conventional carbon-intensive materials across multiple industries. Now today we want to focus on architecture and the building industry, which is of course one of the most carbon-intensive industries also. And we have a product. Let's see if I can. Oh, that was the wrong one. Well, yeah. So PaperShell, a 100% biogenic material based on paper that is stronger than most plastics and lighter than aluminum and can replace carbon-intensive materials such as also glass fiber or carbon fiber in different industries and contexts. Our main USP from the beginning of the company, the whole idea about PaperShell is to reduce carbon emissions drastically by replacing bad materials out there. If we do this by just replacing materials with PaperShell, such as glass fiber, plastics, and so on, we can reduce carbon emissions by up to 98% just with the replacement. Our process is patented. We have, of course, intellectual property is protected. And we are not on a lab scale. We actually have a factory up and running, and we can talk about that maybe throughout the panel a bit more, how important production and scale is and how hard it is also. Yep. I mentioned the replacement and avoidance potential of PaperShell, but of course the holy grail is circularity, a full closed loop, full material loop in praxis, not just in theory. So we introduce here our circular bioeconomy, closing the material loop, and we can talk about that also throughout the panel, how we bring back the material into its biogenic flow and turn it effectively back into soil to grow new trees. and promote biodiversity, ideally. If we do this, just a small comment here, then we convert, or we become a carbon sink in the whole system. So yeah, this image just summarizes the whole flow. Maybe if you would like, we can look into this also in detail throughout the talk.
We will for sure.
Nice. Yeah, and then one of our industries that we love to work with or towards is architecture and the building industry. And now I have the honor also this year during Design Week to launch our recent innovation, which is a alternative to corrugated steel. We call it wood metal sinus because of the form that it has, which is not on the photo here. It is, in a second, this one. So our recent product in our portfolio, which is now available also for to buy. We can talk about that also more in detail. And carbon reduction, I think all the details we will take throughout the next 30 minutes. And I will, no.
Hello everybody, I'm Nicole Soligo, I'm working in Aquafil. And here, I'm here to present a project that Aquafil has done together with other companies. In particular, Aquafil is a chemical company. I'm doing product manager in Aquafil. So I'm in both sides, technical, commercial, and a little bit of marketing. In particular, Aquafil, it's a chemical company producing nylon. So nylon is one of the 100 type of plastics that everybody says that plastic is a problem. Plastic should be a problem, yes, for sure, but should be also a resource. And Aquafil, since 2011, has found that this resource can be really the future for circular economy. When I talk circular economy, I talk about being sustainable in 360 degrees, so both regarding environmental sustainability, social sustainability, but by the way, especially when you are in a large scale production, also economically sustainable. So since many years, now 15 years, we found a way to chemically regenerated waste. So we collect different kind of nylon waste all over the world, coming from fishing nets, that is, let me say, the more sexy waste to have. But we don't only collect fishing nets, we collect also carpet, textile, injection molded part, whatever is nylon has to come to our warehouse and has to be recycled by us. We don't do mechanical recycling, because mechanical recycling, even if it's a good option, we think that as some limitations, especially if you have to do again the same product with the same performance, mechanical and aesthetical, of the yarn, fibers, or polymers and compound that you were used to use as a virgin material. So thanks to our process, that is a chemical regeneration, we can come back to the building blocks, to the monomer of the nylon, and we recreate again the polymer, but that is not coming from oil, but is coming from waste. So after this maybe too long introduction of Aquafil and of Econyl, that is the chemically regenerated nylon, I would love to pass to this project that we have carried on together with other companies, like Caracal, that is a company, Italian company producing robot for 3D printing, University of Trento, Indivenire, and Trentino Sviluppo, which the goal was to use Econyl for producing large-scale prototypes for interiors, but not only. Now we are also thinking about outdoors applications. And the problem for this application was that normally nylon is put together with glass fiber. Of course, this is, let me say, reducing the possibility of the recyclability. So we have developed this product that is called MAGRITTE, which is basically a mix of econyl, so a polyamide 6 coming from waste, plus a little bit of nature, because inside there is a clay, which name is morillonate, but okay, too technical. That is giving the properties of being printed with the 3D printer, but also mechanical properties to the final project, or to the final object. The plus is, of course, that in this way we can recycle it through our regeneration process. I think after I have a short video. Thank you. Which is just quickly showing you the process of 3D printing. Of course, 3D printing for us is a good technology also for experimenting and to see if the material could be used. But later on, the next step should be also to give this product, this new development for other application in injection molding, so in furniture, but not only.
Sounds great.
Thank you.
Wonderful. So my name is Stefan. I'm the business developer of the deep tech startup Parastruct. I just wait for the slide for a second. We are Austrian based. We stem from the Alps, and our mission and vision is to enable a circular economy profitably and competitively. How do we do that? Parastruct has an expertise in and know-how in the material technology sector, technical chemistry, and building engineering. So what we focus on is solely industrial residues to be transformed into building materials or production materials for interior and furniture design. The big difference that we make is we do not use any resin or glue, and we are solely binding our materials minerally. So we also don't use cement, and this can result in stuff like screed, replacing a huge building component, or OSB or MDF panels. Maybe to just explain a little, we really work for different kinds of industries. It could be the steel industry, the aluminum industry, it can be stone quarries like marble quarries, but also demolition waste is a source to refine our binders. What results in furniture boards, block materials that can be machined like usual carpentry tools, furniture industry like. It can be all castable. This means it is possible to also design free forms in anyhow, and it's possible to make astonishing aesthetic surfaces, but also drywalling. So we replace really the formaldehyde in the OSB MDF sector, we replace the cement in the building materials sector, and finally, and that's the greatest point about this graphic, we can mill it down and use it as the filler material up to 90% of the next product cycle, or we regain our binders by pyrolysis, and then we result in biochar and binder as a new secondary material. In this way, we try to establish an industrial symbiosis that benefits the producer, those who have now cost for waste management, to turn their liabilities into opportunities. We are just a young startup with 3 years being established. We are just about 10 people. And so our approach as a hybrid team spanning between Berlin, Vienna, and Innsbruck, Austria and Germany, is to offer a license-based production model for our material recipes to those who already produce building materials. This means as soon as you get in touch with us, it's possible to start rapidly pioneering circular economy at a competitive edge. And the future vision of it would be that we can be resiliently redesigning and reshaping our built environment, but also our living spaces in a sustainable and profitable manner. Let's see, I think, yeah, that's maybe the summary. We try to bring these advantages and future-proof approach that turns huge industries that may more focus on profits into a circular economy by purpose, because taking back the resources and digging up the ground for virgin materials is a huge advantage for all of us and the children to come. Yeah, that's it about.
Thank you for the final, sentence, which kind of put in a very positive, let's say, even for future forward in looking. And but we have a bunch of questions to ask ourselves, and those are a bit of a structure of what is about to happen among us and among the people in the public. So the idea is actually that, well, the name of this talk is Engineered Circularity. So we expect there will be a series of, let's say, technical steps, technical process to be done. And of course, there's whatever needs to be done for, let's say, a linear production route, and whatever else actually distinguish it from a circular production route. So the question is, what can you identify? And of course, maybe we can again start with the same order, if it's fine for you, to identify what are actually the proper practical, technical processes which are actually making what you do circular and non-linear. Is that understandable as a question? Of course.
Yeah, I think so. I will maybe start by thinking or reflecting about what circularity means for us, and then go into the engineering part of things. Of course, engineering is key, but circularity. I mean, we follow a bunch of principles that are a bit of the guiding stars that determine if something is circular or linear. Maybe also worth mentioning that currently, even though a lot has happened in the last years, the status quo is still linear economy. We are still very linear in our ways as we do it. That has, of course, to do that there is momentum, it's business as usual, it's very hard to change, we can discuss all this. But one thing is interesting is that we agree all that we need to change, but nothing really is happening. So anyway, circularity, the first thing that comes to mind is, and I think it came up a few times, is waste, that we don't have waste, zero waste, not just a little bit, zero. That's one thing. The second is that we use our materials in the highest value, and again, keyword, using it as long as possible. It's something that for us is key, that we have a material or a product, a material in the form of a product that is that has a use cycle that is rather long and can even be reused multiple times. So then you have a whole circularity in its own. And then, yeah, there I would maybe say these are the main two ones for us. But then if we just look at circularity as one thing, then there is the whole financial side of it also, which I think that's the biggest struggle, is to convert or to translate all these ideas and these also good ideas into effective business models that can be used on scale and actually do what they are supposed to do. So it has to be financially sound. And I don't like in that sense, the word sustainable is actually quite good to use. It has to be a sustainable business model, something that actually sustains the future and our growth forward. So green growth might be the keyword here. Now you asked about engineering, and of course for us who focus a lot on automation and production, and there's, I mean, that's a whole world behind just showcasing the material as it comes out of the production lines. Engineering is one of the most used words in our company, probably. And something that I realized recently is that we maybe specifically try to replace all these products and materials that come out of the current linear business models and production models. We have spent so many engineering hours on developing those materials that surround us that it is very, very tricky to keep up with that, to build something in a short time that can actually do the trick. So we are really trying to speed up. We have no time to waste here as well, to keep up with all these engineering hours that have been spent on plastics, metals, and so on, and to provide a material that is on the same quality level and on the same engineered technical level to keep up. Now I can keep going, but I think I'm going to give it to
All right. Yes, exactly. The word was really about even technically what are the steps in production-wise and so on, such as instead of like recovering waste or like even just logistically thinking and designing a system to recover and to grab. But what you just aligned was actually greatly aligned with the question. You repeat a couple times like replacing linear materials, and of course this also goes in line with performances, which is something which is, I guess, quite a challenge for all of you, right? Yeah. But we can move on, right? That was quite
just one comment to what you said, because I could have said that input material, we are absolutely capable of using recycled paper, for example, in our production process. The problem is, though, that these material streams are very inconsistent. It is something we have to be super flexible, and we don't know also how the technical specifications down the line. I mean, we can't test that all the time, you know, and these variances are really tricky to translate into production.
Challenges that are, I guess, quite known, renowned. Thank you.
Thank you. I hope that I am able to remember again your question, because many times
straight away.
No, I got it.
Good point.
If I have question, I will come back. No, I think the topic now is a little bit to explain what is circularity for our point of view, for our companies. As I anticipated before, we are a chemical company. We are a plastic producer. We are really under the big eyes of everybody. Because we are producing this material that everybody don't want to use anymore, or specifically want to substitute with something else, which is really good as well. Also because this is, I think, putting in place a lot of innovation, a lot of new companies coming out, startups, and but yes, at the same time, I think that we can work in circularity in two different ways. Substituting a material, a linear material with a more sustainable and circular one, or at the same time, that is, by the way, the aquafil approach, is to transform a linear chemical into a circular one, using and giving value to the waste, and starting collaborating with the company that are using this waste and this material, because at the end we are an ingredient producer. Okay, we can give our support and we can pass our idea of circularity to them, but it's the people that are doing design and that they are developing a product that has to start thinking on circularity. So if you don't design a product with a end in mind, so with the eco-design approach, we call it now, but also others, you cannot pretend to have a final product that is circular. So, for example, also for this project, for this MAGRITTE project, we faced with a big problem. The problem was normally for this particular application, circular resin, that is in this case Iconyl, it's mixed with something that is making the final product not circular anymore. And that's tricky, okay? And so we started from the hand, so developing something that was monomaterial, or having something that at least let us and give us the possibility to recycle the product at the end of the life. So that's also why we decided 3D printing is something good because it's a technology that is not mixing different materials, but is using just one ingredient for most of the time, okay? Not always, but it's one extruder extruding just one material, so that's it. And we started developing this material with this concept. Of course, we can talk about circularity in different way. From my point of view and also from the experience of Aquafil, at the end, the bottleneck to do circularity, especially if you do circularity with big volumes, the bottleneck is to find the waste, stream, to manage them, especially in the plastic. You should imagine there are hundreds of type of different kind of plastics. We are only recycling nylon, okay? And so we had to find the waste stream of nylon. So this was really the first big challenge that we faced. But you should do, I mean, I think that we should be a chemical company example that has really taken benefits from circularity, because it's also, especially, let me say also in this period, geopolitically speaking, is giving Europe, but not only, an independency from other countries that are into these petrochemicals, market. And I think it's also the future, not only environmentally speaking, but also economically speaking.
Right. Just a couple of comments about,
Yep.
Absolutely, waste provisions are really, of course, a challenge, talking about the steps, the let's say, process to actually make production from linear to circular, and that's definitely a challenge. Not to talk about regulations, not to talk about, well, all the sorting, and also among nylons, of course, there are many types, and I guess you are focused on some of them, and that's really even just breaking through something which is even already difficult to to put together. So, got it, nailed it. Well, thank you.
Thank you.
Yeah, maybe a combination of those stories we just heard. So the one critical aspect for us to stay free from something that is mixed into our materials or make it inhomogeneous is that we focus on the problems of industries. So for industrial production, most likely you always result in a very homogeneous waste stream. Even if you look to the steel and aluminum industry, all the slags that they produce, they already refine a lot to recover some certain metals, some certain components, but then they just have a mineral that is left over, and they have a huge cost. It's about 100,000 of tons per year per production plant. So in that manner, we tackled this challenge, in just using their industrial B2B waste streams. We don't focus on post-consumer, like old paper or used fisher nets. And the second aspect, this has something to do with the legal framework, is that there is this issue that after some company turns their residues into a waste, legally seen, it is not allowed that somebody takes care of it else than a waste management certified company. And additionally, you cannot cross borders. If you want to cross borders with declared waste, it's a huge issue. So we turn this challenge into an opportunity for our customers, as we want to give them, and that's why we are enabling circular materials, the license and the production process to turn their waste on their side into their new product or byproduct. And if they don't agree to do so, we will organize very regionally the production capacity, so others in the region benefit from turning waste into circular materials. So mainly we focus on building materials and architecture. In that manner, it's very important to stay within some quality ratios, that you have large-scale productions. And we are just a young startup, so we are 10 people, yeah, dispersed between 2 countries at least. And that's why we see the biggest opportunity in also building a circular business model that incentivizes any of those stakeholders involved, those who produce the residue, those who want to buy the circular material, those who want to live comfortably but affordably, and thereby incentivize a transformation, not just in the product and the material used for the product, but really the scheme of interaction, the reliability and the legal framework that incentivizes people to change is most likely also money-based. And that's an issue where we really advocate also for a European scheme, not just for startups, that we have a homogeneous market throughout all the countries of the European Union, what is a critical aspect, but also to adapt the waste regulation, as this is a critical point. Anybody who wants to get rid of their stuff has to pay somebody with a license. And in many countries, this is limited to an oligopoly, you know. It's not many companies taking care of those wastes. And that's the big challenges where we try to have that as the competitive advantage. Exactly. And happy to answer any more questions.
Right. Definitely touch some pain points which are quite, yeah, popular, unfortunately. And the idea of like enabling, even let's say facilitating circular economy, really building a system behind it, even as absorbing, dealing with all the challenges behind this system. Like, might allow us to move on to the next question. Maybe, I don't know if it's going to be the last one. I can see Andrea. Maybe when it's time to stop us, wave your hand. Right? And it is about actually scalability, which is, of course, one of the greatest, let's say, challenge. And of course, with scalability, we mean to not only make a model sustainable in terms of like economically, but also potentially make an impact scalable. So when we talk about material replacing, if this goes scalable, we are able to actually I don't know what's that.
No, sto solo chiedendo se avevamo tempo di fare un'altra domanda.
Possiamo tornare alla slide loro, no? Okay, right, so next question. So what does it really take to actually scale, make a circular solution scalable? And bottlenecks, what they are. Right.
Well, scale, that's the scary word. But for us, of course, we are right there. We are about to scale. We have scaled in the last year, and we are going to scale even further. We have been granted, for example, by the EU Innovation Fund 24th package with a project there that is going to mean for us that we are going to significantly scale up. So maybe that's one thing that you get from, you mentioned the EU frameworks. We are lucky here, or proud, that we are part of one that enables us to scale. So that goes, of course, all the way to financing scale. Maybe something that is often, we talked a little bit before the panel, that you want to have the right owners in the company. Investors are really important for a company to be able to scale. Then for us, it is production. We designed our production lines ourselves with a partner, of course. Another keyword, partners are really important. No one scales alone. With the circularity mindset in mind, meaning that we wanted to be able to have flexible production lines, meaning that we can change tooling, we can go from one production to another in a very short time, but at the same time having a automized production. So that's quite tricky. Linear production models, for example, that are, once they are figured out, they do one thing and they do it really well. But the moment you want to change production to something else, they struggle. So that problem we wanted to solve with a more flexible approach to our production lines. And then energy cost was, back then when we started designing them, was really a hot topic. So we tried to reduce our energy consumption, or the cost it takes for running the production lines, and we did that together with our partners, and we could reduce energy consumption by up to 80% back then, just in the presses, how they are engineered. So that was a success. But it's multiple of those innovations that are necessary for a new idea, such as this material, to be scalable, to be scaled up. So I mentioned investors. I mentioned production challenges, and then of course downstream. It is super important to have also the right partners. So here we teamed up very early with Arper, for example, an Italian furniture company. Quite known, and they were brave enough to redesign their Katifa, which is a classic model and an icon for them, Katifa 53, with PaperShell, called it Katifa Carta, and were brave to get out, to tell that story, and to also tell that story together with us. So partners downstream, and we like to look at us not just as a supplier of a material. We like to look at us as it's load bearing. It's a good material, good test. But you notice that I didn't talk so much about the actual material properties, which is the starting point of everything. But they are merely the baseline. Everything else there is so much more behind the scenes, of course, that needs to be innovated on and pushed on and implemented and further until you actually get there. So I just maybe one thing, challenges. The third principle in circular economy that I seem to forgot about is end of life, making sure that things can be converted back or maintain their material flow. So whenever you have something that is glued together in a strange way, then you have a real challenge to make sure that it finds its way back into its material flow from a material perspective. And I started to look at products this way. How are they assembled? Do they use any strange glues, or is it, how are they assembled, and how would you get rid of it? It's such a horrible experience to get rid of those types of products. So a beautiful product can be disassembled, and the material parts of it can be converted back into, or brought back into its material flows. So this is how we started looking at it. And you mentioned pyrolysis. We have a biogenic material, so we are a perfect match for converting it into biochar. And good thing is that we have a very high quality biochar and can this way convert it back into soil. We see it as a high value cycling. So challenges. I think one challenge is that recycling is often understood as the holy grail. Everything recycling. I am not convinced that this is the best or the highest value of materials. The idea is simple, but the reality is often not mirroring what recycling is. It's often downcycling. You often have some compromise on the quality side, and so on. It's also energy intensive with certain materials, so it depends a little bit. It's more complex is probably what I want to say here. And there's a challenge that we try to oversimplify something that is actually complex and needs a more nuanced approach. And then circularity, one big issue is take-back systems, making sure if we want to circulate our material end of life after it has been used, and let's say we sell a facade or we sell a bunch of chairs to consumers, then after 10 years, 15 years, how do we make sure that they find their way back into the right material flow? that I don't think anyone has figured out yet properly. So,
Well,
no. And it's something that really affects most companies. It's not something that only we would solve or you. It is something that we have to solve together. And I do also think it's something that's going to be in from the contract stage, right from the beginning. But those two challenges I would mention.
from product to system, of course, we want to promote the fact that building system around products which make them, circular. That's the right word, and it's definitely one of the challenges. And as I said, with times also comes with times plays its game. It's difficult to make it work, or even just to bet in that sense. Well, let's say that now with all the tracking systems, also I'm not talking about digital product passport, but also this is supposed to be easier into, let's say, to manage, not to realize 100%, but yeah, right. And let's move on.
I mean, I will be very quickly because for us, scaling up, so have a bigger production is not the point after so many years, but the point is scaling up the market from my point of view. I mean, now, I hope to explain it correctly, but I mean, now circularity or sustainability, it's a word that everybody are abusing sometimes, and is making also the people and the final user a little bit annoyed after so many years of things, and
Not
after
sexy anymore. Not sexy anymore.
Not sexy anymore. Now, okay, everybody's talking about AI, but okay, you too.
It's already not becoming sexy anymore.
And it's also not becoming sexy anymore. So, I mean, I think, especially for a company that like us that has invested so many money and so many effort in a period where nobody was investing in circularity because it was 2010, so nobody was talking about it. Now we have to survive. Now we have to continue our journey that we feel that is still the future. But at the same time, we have to scale up that the people, the final user, the market has to be convinced that this is and has to be the future and has to be a concrete example. I mean, it's something working. The fact is that the people and the market and the decision makers has to be convinced that this can be the future for everybody. So then, of course, you have to scale up the resources. So you have to continue to work in the products in order to make them recyclable. Because, an example, I think we are collecting most of the nylon waste present all over the world, or the one that the others that are not taking for mechanical recycling or other recycling. So we have, I mean, it's, we say in Italian that it's like a cat that is eating the coda, how to say, the back.
The dog, right? Dog is eating, not
Yeah.
cat. Okay.
But okay,
Yes,
nevertheless,
he's trying to bite his own
okay.
tail. Yeah.
Because of course, if you do circularity, you need the waste. So if you have the waste, it means you are producing, you know? So you cannot imagine a future without a production, without a, so at the same time, you have to produce products. These products has to be recyclable and or circular, to say, and you have to find them and you have to make them as easier as possible to be catched by the company that are doing something else from the waste. And this, I think, will be the most the biggest challenge for the futures and the biggest scaling up that we need to push, and the governments need to push in terms of effort, money, and investments.
Definitely on the same page.
Yeah, maybe a brief ending from my side to this question. We are quite early still. We are incorporated since 3 years. We are a team of 10. So for us, scaling is now to the future. How do we tackle these challenges that we see? On a one thing, it is our material technology is deep tech. This is really something in the microscopic area where we have the know-how how to bind everything. But the process of mechanical, mostly mechanical recycling is something that is established all over the planet, at least in the European Union. There is really no doubt that we can shred, mill, sieve, and mix and fill into packets some dry mixes that are ready for use for purpose. So in that manner, we see scaling not as an issue of scaling our organization or to scale out over different industries, but to incentivize those who are yet producers, who are yet established, to step into the future in partnership, bind them to our recipe, get the surface area of their sales and customer base, and thereby persuade by functionality, by affordability, by recyclability. And maybe what is the issue with this recycling of waste streams? We tackle it by out categorizing anything engineered like synthetic, loose, anything that is resin based, and then offer in a first step to take care of the waste of an industry like particle boards. MDF OSB boards is a huge industry. They have a huge cutoffs. So we try to make something out of their waste for them. And if they buy into this, we go a step further and we just bring our recipes as the primary product. And then they can really earn more. We get a little license fee. And their customers can bring back the stuff and get a reduction on the next buy. So that's our idea. And on a global or how to say geographical scale, also it is about the business model and the legal way how to approach partnerships. Because if somebody says in Turkey they want to start producing our screed or our biomaterials, they can just start tomorrow. They just have to get in touch and we make our contract. And that's something that differentiates us from the conventional building and materials industry, because they sit on their production capacity everywhere. And if we can incentivize them to earn more, be better, circular, and quicker, then everybody wins. And that's the way to scale, I guess. And I hope to tell in 2 or 3 years some other stories about it. Thank you.
Great, actually. Well, I guess we are about to close, and to probably maybe just briefly say the last few words. If you want to add anything or just a last comment, otherwise we close it down and we thank Isola for letting us share our thoughts. But
yeah, nice meeting all of you, and let's talk opportunities and get going. Yeah.
All right.
Yeah, exactly. Thank you so much. I think it was a very nice conversation. Also, companies that are doing completely different things, but with the fil rouge that is circularity and engineering new material that is always the future. I'm a material engineer, so sorry for that I trust so much in materials, but they are everywhere, and they has to be one of the strongest movement for innovation from my point of view.
You're in a good company, I would say, as material passionate.
Yeah, thank you too. It's super nice to be here. And but maybe one last comment.
Right.
We talked about sustainability and how hollow the word is sometimes. For us, it becomes a new word that we use recently a lot is resilience, meaning that there is more highlight on the supply chains. We try to be local. We are local. We are very local. But from a European perspective, especially in the current climate globally, it becomes more and more relevant to be resilient. And of course, that means a lot. But we need to bring back production to Europe. We need to make sure that our supply chains are as local as possible and create a independence here. So that maybe might be a final word from our side.
Great,
from my
actually, final thought, like definitely in relation to what is going on today is, and what we see in Europe that is promoting, let's say, circularity, and then it's new about the ESPR amendments and things are about to happen, and a great, like, for you to make actually Europe like been promoting circular economy and materials. Thank you.